We should watch the French. What?
Okay, so yesterday we looked at scale factors to determine whether an image was enlarged or reduced. So now we're going to look at its cousins, scales. Scales also tell us if an image has been enlarged or reduced. Now, I'm going to be kind of vague with the relationship, other than just saying cousins, between scale factors and scales. But at the end of the class, we're going to solidify that and make sure we're well aware of what that relationship is. Okay, so we're going to be vague as you kind of develop it yourself, and at the end we'll make sure that we're all in charge. And, vague? It means, there you go, thank you. So scales can be converted to scale factors to calculate dimensions of the diagram or the actual object. Okay. Or actual size of the real object. Yeah, it's kind of weird. English don't make sense. Sure. So scales is a comparison between the size of the actual size of an object and the size of its diagram. So we have A and D. And that's kind of what we're using with the terminology. D for diagram, A for actual. Now diagram, we could also use model. What other words could you represent diagram? Picture. What else? Maybe a statue. Okay. So those words are representing a diagram, model, picture, statue. The actual object is the actual object is the actual object. It doesn't change. Okay, so it's almost easier to pick out A and know, okay, diagram is the other number that we're talking about. It's the other item. So we can write this as a ratio, D dot dot A, for example, 3 to 4. Or as a fraction, the 3 goes on top, the 4 goes on the bottom. So it would be D over A. We can also write as a percent. 3/4 is 75%. We don't use the percent too much. Sometimes we use the fraction, but often we're going to raise a ratio. Now if we have one ratio as 1 to 32, that means 1 centimeter of the diagram, I should use the word of, 1 centimeter of the diagram, or model, or picture, represents 32 centimeters of the actual object. Okay. So 1 to 32 is telling us that the diagram is a lot bigger than the model, right? It has 32 centimeters for only 1 centimeter of the diagram. If that number was reversed, 32 to 1, that means the picture is a lot larger than the diagram. So that would be like maybe a big picture of a fly. Okay? Something like that. Anything we look at through a microscope would be like that. So scales are always, couple rules. Number 1, written as diagram to actual, so D to A. You should write that down 400 times in your homework so it's memorized. Okay. Or as a fraction, D over A. And when we're doing our math, that's how we need to write it to make it easy math. You have to reduce it just like a fraction. So if we have 6 over 18, that's just like 6 dot dot 18. So we would divide both sides by what? Nope, 6. Okay? And we get 1 to 3. Okay, lowest terms always. You also must have them as the same units. Now when you see a scale, if we give you a scale, the convention is centimeters to centimeters, unless we write different units. So if we write nothing, it's centimeters to centimeters. That's kind of the standard here. Good. So 45 to 90, we want to divide. Sorry?
1, 2 dots here.
Yeah, it's always 2 dots in the middle, colon.
That'd be 1 and 2 plus 45 plus 1.
Oh, thank you. Yes, divide by 45, divide by 45. Always try dividing by your smallest number so you get one of the numbers to 1. Okay. Another example, let's say we have 25 to 80. So what we're going to do first is divide them both by the smallest number. And we get 1 to what? 80 divided by 25, 3.2. Okay. So what we can do though is, now some math teachers say, hey, you know what? There's no problem with this. That's okay. Having a decimal in there is fine. And we'd see quite a bit of that. But some people say, oh, we shouldn't ever have decimals, so we should multiply to get rid of it. Yes, Kezia?
So when you divide, you're not like dividing by necessarily like the number that fits into it. Just dividing by the
Yeah, you want to convert it to 1. Now, here's an interesting fact, is some teachers will say you shouldn't have a decimal there. Some will say it's okay. So what you could do is put that into lowest terms. Divide them both by 5. Okay, or if you times this by 5, both of them, you'll get 5 to 16. And so these would be whole numbers. And some teachers say, oh, you should always have whole numbers. Now, I'll tell you right now, I'm okay with the decimals, but if it's like 1 to 2.5, I'm kind of expecting you to take the 0.5 and convert it to 5. So I'm okay with other decimals, but if it's 0.5, let's change that. Does that sound fair?
Okay.
Okay, like 0.5 times it by 2 gets rid of the 0.5. Okay, let's move on then. Practice this. Okay, read this little box here. Underline your diagram number, underline your actual number. Go. Diagram is 4. Actual is 12. Scale is D dot dot A. Okay. So we'd say diagram 2 actual. So we would go 4 to 12 using your colon. Then divide both of them by 1 and we get 1 dot dot 3. So 1 to 3. Like, why would I divide by 1? I have neither do I. Oh, I'm thinking of getting it to 1. There we go. So to get to 1, divide by 4, 1 to 3. Okay. So looking at the scale now, what is it telling you? Which one's larger, the diagram or the actual object? Yeah, the actual object's larger because it's 3 and the diagram's only 1. It's a larger number. Okay, read the next one. Come up with your scale again, please. Start by writing down D colon A, or D2A. So instead of saying colon, we should use the word 2. Yeah. So D to A, divide both of them by 8, and the number we get, 22 divided by 8, is 2.75.
I tried times and it didn't work.
Yeah, you know what? This is a weird one, isn't it? So what's 75 as a fraction?
3 over 4.
So what should we multiply by to get rid of the fraction? Times it by 4. Okay?
I don't want to do that.
So just a little work, just to kind of work on our skills a bit. Times it by 4, et voila. Your decimal is gone because the fraction will be gone.
How'd you do that?
We've done this with our algebra before. So this would be
111.
11 to
11?
4. So we have to multiply them both by 4.
Okay.
Good.
Okay, so
Yes.
why do we have to do
What I did is I just did 22 divided by 2.
Yeah, so you put in those terms. And I was just going to say, what you could do is you could just divide it by lowest, put in the lowest terms. Okay. So if you do get a decimal, maybe you want to go back up and start again and just reduce it to lowest terms. Okay. Just kind of, messing with you a bit here. I know it's a little bit above some of you. Don't worry about that.
It's above me.
Yeah, Sarah.
I'm drowning right now. Cool.
Try and reduce it as best as possible. Yeah, I'd say yes for that. Okay, it's not going to happen that often. Okay. Good. The next one. Read the question. What's wrong? What's the problem? Read, Erica. Dustin.
One of the numbers is meters and the other one is centimeters.
Exactly. One's in meters, one's in centimeters. So in order to have the same units, we got to have centimeters to centimeters. So 1 meter equals how many centimeters? 100. If you're unsure, think about how big a meter stick is. Right? And then how many centimeters should be in that meter stick? So if we have 27 meters, then how many centimeters do we have? 2,700. Okay, or 2,700. So what I do is you're just taking the zeros and putting them on the end. So you're multiplying this by 100 to get to 2,700. Okay with that? Okay. So now we can go diagram to actual. And so we're going to get 300 to 1.
You have to write like that, or can you write 1 to 3?
That's a completely different thing.
Oh, I've been doing that.
Yeah, it must be exactly as I've written it. So this is saying the diagram is a lot larger than the actual object, kind of like a microscope would work. Okay? Any questions? Good. So let's get some applications. What we want to do when we're finding measurements, we want to set up a proportion, which is 2 equal fractions. So we can get 1 fraction equals the other fraction, then we'll solve. Now for your fractions, remember your diagram goes on top, your actual goes on the bottom. So if you read the first question about the skateboard, here's your scale. Please convert your scale to a fraction. Look up above if you're unsure.
1 over 14.
Or is it 14 over 1?
I don't know.
Then look in your notes up above.
Was it 14
Look in
over
your
1?
notes up above. I'm not.
14 over 1?
Nope.
Over 14. Oh, I said
It's 1 over
I
14.
said that, then you're like,
Diagram over actual. Be sure. So here's diagram, there's actual.
this is painful.
No, it's not. It's easy. Okay. So now we have to come up with another fraction. What's the actual length? No, that's your diagram. Your actual length, you don't know. So we'll call it X. You can call it A if you want. 5.5 is your diagram length that goes on top where your D measurement should be. So, how do we get rid of this divide by X part? Actually, I'll show you the easy math. Sometimes this works out. How do you go from 1 to 5.5? Times by 5.5. What are we going to have to do at the bottom? And so we get X equals what? 14 times 5.5, 77.
I did that.
Okay. So a quick little sentence. Actual length is 77. And you won't get full marks. Why?
No meters, no units.
No units. 77 centimeters. Okay?
I actually did that.
Good job.
No, they
Any questions? Okay, we're going to go now. Today's math is sometimes it's going to be really cooked up like that, and it's going to be easy to do. But we will get harder math tomorrow, so we'll show you later on how to deal with harder stuff. Let's go to the next question first, though. We have a nice, beautiful salmon. Yum, yum.
I love salmon. I love
Okay.
food, actually.
Please set up your 2 fractions. Diagram over actual. Go for it. Here's your scale. That'll be your first fraction. See how they use that decimal? That's why I don't mind too much. So 46, that'll be actual. We're trying to find x. So how would you go from 46 to 9.2?
Oh, wait.
Divide, so 46 divided by 9.2 means you would have to divide by 5. So if you're going the other direction, you wouldn't divide by 5, you would times by 5. So we get x equals 5. Quick little sentence.
The actual,
Yeah. The diagram is
Okay. Or you should say the fish in the diagram if you really want to get technical.
No.
Sarah?
in the top, then why did you times by?
Well, which direction am I going here?
Oh, that's it.
Yeah, so here I'm going from 46 to the other fraction. So if I'm going this direction, I'll have to do multiplication. Okay? Kezia,
Why is X on the top?
what number is 46? You caught a salmon. So this would be your actual measurement, because that's the length of the true salmon. So that must go in the bottom, because it's always D over A. Okay?
Oh, and the one at the top is like, what's that?
Yeah. Yes, go ahead. You good? Yep, question?
It's not really a question.
Yep.
You know, like the diagrams,
Hmm?
what I do to get the answer is wherever the x is, like here, I do that times that divided by 5.
That's wrong.
Cross multiplication, isn't it?
No. It works out, but you don't want to be doing that. We're going to go over this in a second. We're going to go over real rules. Right now, we're just using equivalent fractions to figure it out. It's only going to work for some questions, not a lot of them. Okay. Okay, the maps. This is going to be a question on your quiz, not quiz, or homework, sorry. So we are flying from Dawson City in the Yukon to Whitehorse. If you fly there, it's 540 kilometers. But on the map, it's only 3 centimeters. Okay, so let's start by doing the scale. Diagram to actual. Please write that down. Write your scale, please. So you should have 3 centimeters to 540 kilometers. The units are super important here, aren't they? Now we don't want it to be in kilometers, so we're going to have to convert 540 into centimeters. So let's start here. 1 kilometer equals how many meters? 1,000. So then 18, sorry.
It's right there, isn't it? Oh, you
Yeah, just relax. What if I don't give you that?
But it's there.
Don't butt me. I don't like that. Divide by 3. Let's put this in lowest terms first. You'll see why in a second. So 1 centimeter is 180 kilometers. Okay. So if we have 180 kilometers, how many meters is that? 180, and how many zeros? 3. Okay, so you have to multiply by 1,000. Now if we have 1 meter, how many centimeters is that? 100. So if we have 180,000 meters, how many centimeters is that?
Times it by 100.
Yep, times it by 100. So you're going to have to put down 2 more zeros. Okay. So we can say 1 centimeter on the map represents 18 million centimeters of the actual object. Okay. Now on a map scale, it's always going to be like that. You see that all the time on all the maps. However, if you were going to actually do any work, you would convert it, but you got to watch your units very carefully. So usually I would use the top one for work, but technically this is the correct way of doing the scale because you have the same units. Okay. Now, sometimes we'll give you, we'll give you this. So we can say if it's 180 kilometers, then you're going to write down 180 and put the zeros on. So you multiply it by 100,000. So now you have to have 1, 2, 3, 4, 5. Okay. So sometimes we'll give you that just to make it a little bit easier for you. But I want you to be able to do this because that's going to be a lot more powerful because it's going to help you with a whole bunch more questions. Rather than know one simple trick, know how to do everything. Okay. Good. Now scale factor. For the scale factor, you're going to go diagram over actual. So it's going to be 1 over 18 million. That's what your scale factor is. Now, your textbook will actually get you to divide to a decimal. However, this is such a small number, they use scientific notation. Okay, and I'll just show you what it looks like on your calculator. 1 divided by 18 million. So that's 5.5 times 10 to the exponent -8. And we don't teach scientific notation anymore. You'll see that in chemistry and stuff. Really, really large or really, really small numbers. Is that a small number or a large number, Tony? Small number, guess. You okay? I know, don't worry about it. Okay. Good. Yeah, you don't need to know that. Don't need to know that, right? Okay, proportions. So up above we had easy ones. Now we have some harder ones. So we did this in our algebra. In fact, that was our third question on the algebra test. So the rules for solving. Do the opposite. Keep it equal. The first question, where is X? In the bottom. It's the basement. There's spiders. It's scared. So this is 10 what X? 10 times X? 10 minus X? 10 plus X? Divide. So if we see division, what should we do to get rid of? Times it by X. Just the right side? No. So the opposite of divide is to multiply. These cancel. X times 9 over 4 is 9 times X over 4. So it's still a multiplication, right? These are exactly the same. It's a multiply. But on the right side, the X's can't divide to 1. Good. What do you guys want to get rid of next? 4. Now, what operation is it? It is a division, so we should do a multiplication. So times both sides by 4. The 4's on the left divide to 1. So we're left with 9x equals 40. Go to 1 decimal, please. 1 decimal, please. 4.4 repeating, or if I said to 1 decimal like I did, 4.4. Okay. Okay, solve the next one yourself. Go. Show all the work, tons of work, please. So what's the first step? Yes, Dustin? Why times, Dustin? Good. So it's a division, so he times it by x. Good job. So we get 5 times x divided by 7 equals 11. What's the next step? Rabia. Good. So it's the opposite of divide by 7. Again, these divide to 1, so we're left with 5x equals 77. Then divide, and we get what? 77 divided by 5, 15.4. Any questions? Do the next two all by yourself. Go. 1 decimal, please. Check your rounding. $25.7 for the first one. Hands up if you got that. Any questions with the first one? Why is it different? Kezia? Good. Yeah, does it make it easier or harder with x being on the top? Totally easier, right? All you gotta do is the opposite of divide by 36 and you're good. Good. And the last one, 71.0. Hands up if you got that. Good. So you can still use these for the easy work today. They are still going to work for questions like example 1 and 2, the skateboard and the fish. Okay, totally will. But equivalent fractions, sometimes a little bit easier for us to do the math using that. Tomorrow, though, we'll need to be able to do these ones. So we want to practice. So we practice more tomorrow. For your homework, you will need to measure. So the grid